In this example, we're looking at scale pans or lifts. The question says, a light scale pan is attached to a vertical light inextensible string. So these light mean there's no mass in those particular aspects of the system. Inextensible, no elasticity in the string. The scale pan carries two masses A and B. Mass A is 400 grams and mass B is 600 grams. A rests on top of B as shown in the diagram. So you could maybe apply this to lifts, as I say, but this is a scale pan, just something that is holding two weights. Now this can become a little tricky, and I think really it's worth just talking about what we could do in this system. So we could, we're going to be resolving forces in a second, but we could be talking about the whole system. Now if we were thinking about the whole system, we would have, let's just draw the forces on there, we would be looking at that, we would have a 1G force acting down because that is the weight of the whole system, there's no weight on the scale pan, and we have a tension acting up. Sorry, one thing I didn't mention when I was reading it, the scale pan is raised vertically with acceleration of 0.5 meters per second. So that would be my force diagram for the whole system. Okay, so what I could also think about is just A on its own. So let's just think about what that force would look like, what that force diagram would look like. So I've got my A. I'm just thinking about this. Think about the forces that are acting on that. So first of all, I've got a 0.4 G force acting down, which is its weight. But then I've also got B is acting up on A. So there is a force from B acting on A. And I'm just going to call that RAB. Okay, so it's the reaction from B acting on A. Right, so let's just think about B on its own now. So if I was going to just think about the forces acting on B, I would have something that looks like this. So I've got its weight. Now, Newton's third law states that every action has an equal and opposite reaction. Now that means that the force acting from B on A is exactly equal to the force acting from A on B. They're equal and opposite. So these two have the same magnitude, but they're acting in opposite directions. So I'm going to call that BA because that's B on A, and I'm going to call that A on B. Right. Now there is also an effect from the scale pan acting on B. So it's got its weight acting down, it's got a force acting from A acting down, but it's also got a reaction force from the pan onto B. So there's the fact that B is resting on the bottom of the pan, there is a force acting up from the pan on B. Okay, finally, I can also think about the pan. Okay, so let's just think about the pan itself. So what we have on the pan, there is no weight on the pan, it's light. So there's a tension going up, that's what that tension is there. B is sitting on the pan, so this force here is going to be identical acting down there, so R from B onto the pan. Okay, and these two are equal and opposite. So the force from B onto the pan is equal and opposite to the force of the pan onto B. So those are my options. Those are the things we're able to use. So let's just think about this. So I want to find the tension in the string. Okay, so I'm going to use this one for that. So on system, I'm going to go upwards and I'm going to do F equals ma. Okay, so I've got T minus G equals, the mass of the whole system is 1 and the acceleration is 0.5. So T is equal to, let's just make sure we get this right. I'm sure I could have probably do that, but oops. So I've got 0.5 plus 9.8. Okay. Sorry, 0.5 plus 9.8, which is 10.3. Don't think I really needed a calculator for that. Okay, so the next thing I'm going to do is find the normal reaction force between the block A and B. Okay, so I could use either of these, couldn't I? So the force from B on A is the same as the force A on B. So actually this one makes sense here, doesn't it? So at A, I'm going to go up because the acceleration is always the same, isn't it? I'm going to do F equals ma on that. So I've got the reaction force minus 0.4 G is equal to the mass just of A this time, times 0.5. So R is equal to 0.4 times 0.5 plus 0.4 times 9.8. So let's do that. .12 newtons. Okay. Sorry, I do apologise. I've just gone off screen, haven't I? So this is what I was doing here. So at A, so I was using this. I was using this system here. So just at A. So I've got R minus 0.4 G equals 0.4 times 0.5. The acceleration is always up for all of these, isn't it? Okay, so at sorry, this time I want the normal reaction between block B and the scale pan. So I'm after this one here. So I can either have B acting on the scale pan, or I can have the scale pan acting on B. So which one is going to be the easiest to use? Probably this one here. So at the pan, I'm going to go up and I'm going to use F equals ma. So I've got T minus the new R, B on P, equals mass. So the mass is in fact 0 of the scale pan. So actually T is equal to RBP. So the and we know that the tension is 10.3 newtons. So that is the answer. So actually this reaction force here is identical to the tension. So what I was saying here is that the key thing is to thinking about this Newton's third law, which we haven't used a lot so far, but by recognizing that the force of B acting on A is identical to the force acting from A on B, and the same with the pan. So B acting on the pan is the same as the pan acting on B. And thinking about which aspect of the system is going to be the easiest to use to answer individual questions is the key. Okay, hope that was helpful.